And the first question says a concert starts at 1950 and finishes 2 hours 42 minutes later. Forget the time the concert finishes. So we're going to add 2 hours 42 minutes to 1950. 2, 9, 11, 1, 2, 2192. Now, since our minutes cannot be greater than 60, so we take 60 minutes from 92 and add it to 21 as an hour. So it's going to be 22 hours and 32 minutes. Question 2 says find the reciprocal of one whole number 104. So first we convert the mixed number into an improper fraction. We times the denominator by the whole number and add the result to the numerator. 4 times 1 is 4. 4 plus 1 is 5. So 5 over 4. Now we will take the reciprocal of this fraction. When we say reciprocal, basically what we're doing is that we're flipping the fraction. So we're swapping the numerator with the denominator and vice versa. So that gives us 4 over 5. Question 3 says use one of the symbols less than, greater than, or equal to make each statement true. So 2 over 7 is basically 2, 14, 6, add another 0, that's 8, because 56. 4, add another 0, that's going to be 5. So 0.285. I'm going to stop at 3 decimal places. So this is obviously smaller than 0.2861. 99 over 900 and 11%. So 99 over 900 can be simplified to 11 over 100, which is the same as 11%. So that's equal. 1 cube is 1. Anything to the power of 0 is also 1. So again, equal to. Question 4 says Sophia has a piece of fabric of length 5.6 meters. She cuts the fabric into 2 parts with lengths in the ratio of 3:4. Calculate the length of the longer part. So first thing what you're going to do is that you're going to create a fraction out of the ratio for the longer part. So that's going to be 4 over 7. Why 4 over 7? Because obviously the numbers show that 4 is bigger than 3. So that is for the longer part and this is for the smaller part. And when we're creating a fraction out of the ratio, the denominator is always the sum of the values in the ratio. So 3 plus 4 is 7. So that comes down as the denominator and 4 is the numerator. So to find the length, what we do is we times the fraction for the longer part by the length of the fabric, which is 5.6. Now we know 56 divided by 7 is 8. So 5.6 divided by 7 would be 0.8. So 4 times 0.8 is going to be 3.2. That's your answer. Question 5 says 3 bracket 6 negative 4. So we are multiplying a scale factor with a vector. So 3 gets multiplied with 6 and with negative 4. So that's going to give us 18 and negative 12. Then we're adding the vectors. So the x value gets added to the x value and the y to the y value. So that's going to be 4 plus negative 7 and negative 1 plus 5. When we're adding a negative integer to a positive integer, we're basically subtracting them. So 4 minus 7 is negative 3 and negative 1 plus 5 is 4. Negative 3 and 4. Question 6 is a diagram shows a right angle triangle ABC in a quadrilateral AEDC. Find the value of x. So for the value of x, we can see that AEB is a straight line and 122 and x are supplementary angles, which means they add up to 180. So x would be 180 minus 122, and that will leave us with 58 degrees. Next part says find y. So y is over here. So we know that ABC is a right angle triangle. So that means we can find the entire angle C by subtracting 90 and 34 from 180, because sum of angles for a triangle is 180, and that gives us 6 degrees. Now angle C comprises of y and 17, which means y would equal to 56 minus 17, and that will give us 39 degrees. So that's the value of y. Part C says find the value of z. So for the value of z, we know that this is 39. We know this is 58. So z is going to be 360 minus 17 minus 58 minus 34. Why? Because if we highlight this part, this is a quadrilateral over here. Why quadrilateral? Because any shape that has 4 sides is a quadrilateral. So for z, we're going to do 360 minus 17 minus 34 and minus 58, which will equal to 251 degrees. Question 7 says factorize 28x minus 35. So we're going to see what is common between 28x and 35. Both 28 and 35 come in the 7 times table. So if we take 7 common, 28 divided by 7 is 4. X comes as it is. And 35 divided by 7 is 5. So 7 brackets 4x minus 5 is our fully factorized answer. Question 8 says, Edith invests $3,000 in a savings account. The account pays simple interest at a rate of 2.6% per year. Calculate the total interest earned at the end of 3 years. So for simple interest, the formula we're going to use over here is principal amount times the rate of interest times the time period for the interest. So P is 3,000, which is the amount that we invested. R is 2.6 over 100, and time period is 3. So we can cancel out the 2 zeros over here. So that leaves us with 30 times 2.6 times 3. Get rid of this 0 by canceling it out over here and moving the decimal over here. So that leaves us with 3 times 26 times 3 now. Why did we do that? Now we know 30 is 3 times 10. And 10 times the decimal number would mean that we can move the decimal 1 place to the right. So that's exactly what I did. So 3 times 3 is 9. So we're doing 26 times 9. And that basically gives us $234. So as you guys know, for the 2025 syllabus changes, they have made paper 2 a non-calculator paper. So with these small tricks that I'm sharing while solving these questions, you can easily solve the question without immediately grabbing a calculator when a question like this comes. Like, you can easily solve decimals, fractions. As you can see, you do not need a calculator for paper 2. Question 9 says diagram shows part of a regular polygon. The interior angle of the polygon is 132 degrees larger than the exterior angle. Calculate the number of sides of this polygon. So we can see that x plus 132 and x are making a supplementary angle. Both of them lie on a straight line. So when we add the 2 up, the sum would equal to 180. So that's 2x plus 132 equals to 180. 2x equals to 180 minus 132, which basically equals to 48. X would be 48 divided by 2, which basically equals to 24. So now the interior angle would be 24 plus 132, which equals to 156 degrees. Now to find the number of sides, we can use the interior angle formula, which is n minus 2 times 180 divided by n. If they're asking for the sum of interior angles, then you would not divide n minus 2 times 180 by n. So since we have the value of each interior angle, is 156, so we use this formula. We cross multiply to get rid of the fraction and expand the bracket. So that's going to be 180n minus 360. Then we swap 156n with 360. So 360 equals to 180n minus 156n, which basically equals 24n. So n would equal to 360 divided by 24, which equals to 15. So that is the number of sides for this regular polygon. Question 10 says Jaganta plays a game with a friend. She can win, lose, or draw the game. The probability that she wins the game is 0.28. She is twice as likely to draw the game as to lose the game. Work out the probability that she loses the game. So if winning is 0.28, so then losing would be 1 minus 0.28. But that would equal to x plus 2x. Why x plus 2x? Because it says that she is twice as likely to draw the game as to lose the game. So 1 minus 0.28 would give us the probability of her losing or getting a draw. Because there are three different things happening. There's win, lose, or draw. So if we subtract the probability of winning from 1, that gives us the probability of her drawing or losing. So 1 minus 0.28 gives us 0.72. And x plus 2x is 3x. So 0.72 divided by 3 equals to x, which is going to be 0.24. Now, in the question said that she's twice as likely to draw the game to lose the game. So that means the probability of her losing the game is 0.24. And the probability of her getting a draw would be 0.48. Then part B says, Jacinda plays the game 150 times. Find the expected number of times that she wins. So you multiply the probability of her winning with the number of times she plays the game. So 0.28 times 150, and that would give us 42. So she would win the game 42 times. Next question says, without using a calculator, work out 5 whole number 1 over 3 minus 3 whole number 4 over 7. You must show all your working and give your answer as a mixed number in simplest form. So first thing first, we need to convert the mixed numbers into an improper fraction. And to do that, we'll multiply the denominator by the whole number, add the result to the numerator. So 5 times 3 is 15. 15 plus 1 is 16. Denominator remains the same as 3. Then for the next fraction, 7 times 3 is 21. And 21 plus 4 is 25. So 25 over 7. Now, whenever we're adding or subtracting fractions with unlike denominators, we need to make the denominators equal first. So to do that, we'll multiply the first fraction by 7 and the second fraction by 3. So that leaves us with 7 times 16, which is going to be 112, and 25 times 3, which is going to be 75 over 21 for both the numbers, because 7 times 3 is 21. Now, since the denominators are equal, we can combine it as a single fraction and subtract the numerators, which will give us 37 over 21. Now to convert 37 over 21 into a mixed number, we will divide 37 by 21. 21 times 1 is 21. Subtract 37 and 21, which gives us 16. So it's going to be one whole number, 16 over 21. Our answer is going to be one whole number, 16 over 21. Question 12 says, solve the simultaneous equations. You must show all your breaking. So to solve this set of simultaneous equations, we're going to use the elimination method. And the reason why we're using elimination method is because it's going to be easier for us to solve it, because with substitution, when we're making one of the variables a subject, we'll get a fraction. And then we'll have to substitute the fraction equation in the other equation. So to make things easier, let's stick to elimination. So first step is to decide which variable you want to eliminate. I'm going to choose y. Now, to eliminate y, I need to see whether the coefficient of y is the same or not in both the equations. So in the first equation, coefficient of y is 6. In the second equation, the coefficient of y is 2. So to make the coefficients equal, I'm going to multiply the second equation by 3. So the entire equation will get multiplied by 3, not just 2y. So that leaves us with 9y minus 6y equals 51. Negative 51. Now the first equation stays the same, which is 5x plus 6y equals to 9. So once we have made the coefficients equal, the next step is to see what the signs are of the variable that we're trying to eliminate. So in the first equation, y is negative. In the second equation, y is positive. So in order for us to eliminate, we will add them. Why will we add them? Because both the y's have opposite signs. So minus y plus y would give us 0, no y. So this is why we add the two equations. This one is x. Okay, so 9x plus 5x is going to be 14x. Minus 6y plus 6y is going to be 0. And negative 51 plus 9. So that gives us 14x equals to negative 42. And x would be negative 42 divided by 14, which equals to negative 3. Now to get the corresponding y value, we'll substitute x equals to negative 3 into either of the equations. It can be the new equation as well. In each case, you'll get the same answer. So if I pick the first one, 5 times negative 3 plus 6y equals to 9. Negative 15 plus 6y equals to 9. 6y equals to 9 plus 15, which is going to be 24. So y would be 24 divided by 6, which is equal to 4. So when x is negative 3, y is 4. That is your answer. Question 13 says a sequence has nth term of 3n squared minus 1. Find the second term in the sequence. So to find the second term, we will put n equals to 2 in the equation. So 3 times 2 squared minus 1. 3 times 4 minus 1, which is 11. Part B says the table shows the first 5 terms of sequences A and B. So we can see that we have the first 5 terms for both the sequences. We have to find the nth term for both of them. So if you look at the first sequence, the first term is negative 6, then it's negative 2, 2, 6, 10, and so on. So let's first try to find the common difference. So between negative 6 and negative 2, we're adding 4. Then between negative 2 and 2, we're again adding 4. Between 2 and 6, again adding 4, and same case between 6 and 10. So which means we have a common difference of 4. So for A, as I've told you previously, when we're trying to find the nth term, if we have a common difference, we multiply the common difference by n first. So 4 times n. Now, if we assume that 4n is our nth term, and we try to find the first term from 4n, so that's going to be 4 times 1, which gives us 4. Now, we can see that the first term is -6, not 4. Hence, to turn 4 into -6, we need to subtract 10 from it. So that gives us -6. So if we use 4n minus 10 as the nth term and try to find, let's say, the fourth term. So 4 times 4 minus 10, 16 minus 10, and that is 6, which is exactly what the fourth term is. So that means our nth term for sequence A is 4n minus 10. Now for sequence B, we have 3, 17, 55, 129, and 251. We can clearly see that there's no common difference between these terms. For sequence B, let's try to see when we get a common difference between these terms. So if we start subtracting them, between 3 and 17, we have a difference of 14. Between 55 and 17, we have a difference of 38. Between 129 and 55, we have a difference of 74. And between 251 and 129, we have a difference of 122. Now, if we find the second difference, between 38 and 14, we have a difference of 24. Between 74 and 38, we have a difference of 36. And between 122 and 74, we have a difference of 48. Now let's find the third difference. So between 36 and 24, there's a difference of 12. And between 48 and 36 is a difference of 12 as well. So now we can see that the common difference comes at the third difference, not the first or the second. So if we highlight this over here, this is the first difference. This is the second difference. And this over here is the third difference. So since the third difference is common, that means it's going to be a cubic equation. So let's assume that Tn is n cubed now. Now, if we use So since in the cubic equation, we're cubing terms, so we know that 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, and so on. So for the first one, it's 3, which means if we multiply 2 with n cube, that's going to be 2 times 1, which is 2, and then we add 1 to it, that's going to give us a 3. Similarly, for 17, if we do 2 times 2 cube, which is 2 times 8, that's 16. 16 plus 1 is 17. Then 2 times 3 cube, 27 times 2, and then plus 1, that's again 55, which means our nth term for sequence B is going to be 2n cube plus 1. So in this case, you can begin with like the parent sequence for n cube and then manipulate it based on the sequence that they've given and then figure out what your nth term is. Question 14 says two solid steel statues are mathematically similar. The smallest statue has height 12 centimeters and the largest statue has height 15 centimeters. The largest statue has a mass of 2.5 kgs. The density of steel is 8 grams per centimeter cube. Calculate the volume of the smallest statue. So for this, first we find the volume of the largest statue using the density formula. Density equals to mass over volume. Density is given as 8. Mass is 2.5 kgs. So we convert the 2.5 kgs into grams by multiplying it by 1000. because 1 kg equals to 1000 grams. So that's going to be 2500 grams. So over here, we'll have 2500 divided by the volume. So volume equals to 2500 divided by 8, which gives us a value of 312.5 centimeter cube. So we know when shapes are mathematically similar, that means the ratio of the height of the larger statue is to the height of the smaller statue being cubed would equal to the volume of the larger statue divided by the volume of the smaller statue. So that is going to be 15 over 12 cube equals to 312.5 divided by volume of the smaller statue. So 15 over 12 can be simplified to 5 over 4. So when we cube that gives us 125 over 64. Since we're trying to find the value of the smaller statue, so we cross multiply, make the volume of the smaller statue the subject, and we have 312.5 times 64 divided by 125. And that gives us a volume of 160 centimeter cube. Question 15 says students in class P take a test. These statistics show information about their marks. So the lower quartile is 38, median is 53, interquartile is 28, range is 81, and the highest mark is 96. We have to draw a box and whisker plot to represent this information. If the range is 81, range is basically max minus min. So 81 equals to 96 minus the minimum value. So that is going to be 96 minus 81, which gives us 15. Scale, this is 1, 2, 3, 4, 5. So this is 10. Then 1, 2, 3. So 1, 2, 3, 4. So this is going to be 15 over here in the middle over here. Then for maximum it was 96. So if this is 90, 1, 2, 3, 4, 5, this is 90. So 2, 4, 6, this is 96. That's 96. Then for median, that's 53. So 1, 2, 3, 4, 5, 50. So in the middle over here, that's your median. Now they've given us the lower quartile, which is 38. 2, 3, 4, 5. This is 30. This is 38. And then for the upper quartile, we need to use the interquartile range. So IQR equals to upper quartile minus lower quartile. So that's 28 equals to upper quartile minus 38. So 28 plus 38 gives us the upper quartile, which is going to be 66. So that's going to be 2, 4, 6. This is your upper quartile. So if we make this is your box and whisker plot. This is your minimum value. This is your maximum value. This is your lower quartile. This is your upper quartile, and this is your median. Part B says students in class Q take the same test. For class Q, the median is 49 and the interquartile range is 35. Make 2 comments comparing the distribution of marks for class P with that of class Q. So if you look at the median, class P had a median of 53. So that means class Q is scoring less on average because the median is 49. So class Q scores less on average. Then for the interquartile range, Q has an interquartile range of 35 and P had 28. So that shows that the score values are more spread out for class Q. So marks of class Q are more spread out because of the high IQR. Question 16 says diagram shows a sphere of radius 6 centimeters and a cylinder of height 18 centimeters and radius r centimeters. The volume of the sphere is equal to the volume of the cylinder. Calculate the curved surface area of the cylinder, giving your answer in terms of pi. So they've already given us the volume of the sphere, which is v equals to 4/3 pi r cube. So using the radius, we can find the volume. So 4/3 pi times 6 cube, and that gives us a value of 288 pi. Since they want the answer in terms of pi, I'm not going to replace pi with 3.142. Now, the volume is the same for both the shapes, so 288 pi equals to pi r square h, which is the formula for the volume of a cylinder. 288 pi equals to pi times capital R square, because that's what the radius is, and height is 18. So we're going to divide 288 pi by 18 pi. We take the square root on both sides to find the value of r, which will be 4 centimeters. Now, to find the curved surface area of the cylinder, curved surface area has the formula of 2 pi RH. So 2 pi times 4 times 18 will give us the value of 144 pi centimeter square. Question 17 says solve 3x squared minus 7x minus 16 equals to 0. You must show all your working and give your answer correct to 2 decimal places. Since it's identifying that the answer needs to be correct to 2 decimal places, that means we're going to use the quadratic formula. Quadratic formula is x equals to negative b plus minus root of b squared minus 4ac divided by 2a. Now, to figure out the value of a, b, and c, you need to remember that the standard form of quadratic equation is ax squared plus bx plus c, where a is always the coefficient of x squared, b is always the coefficient of x, and c is the constant. So based on our equation, a is going to be 3, b is going to be negative 7, and c is going to be negative 16. So that's negative 7 plus minus root of negative 7 squared minus 4 times 3 times negative 16 divided by 2 times 3. That's positive 7 plus minus 15.52 divided by 6. So one value of x is going to be 3.75, which we get from adding 7 to 15.2 and then dividing by 6. And the other, which is 7 minus 15.5 to divide by 6, is going to be negative 1.42. So 3.75 and negative 1.42 is your answer. Question 18 says g of x equals to 4 to the power of x plus 3. Find x when g of x equals to 1. So we put the function equal to 1. And if you remember, anything to the power of 0 is 1. So if you replace 1 with 4 to the power of 0, that's also equal to 1. So now, if you notice, we have similar bases on both sides, which is 4. And whenever we have similar bases on both sides, we can put the powers equal to each other. So 0 equals to x plus 3, and x equals to negative 3. Then part B says g inverse of 1 over 16. So in order to find that, another thing you need to remember is that if we have an original function, let's say g of x, and then we have the inverse of a function. So whatever is the domain and range of the original function, the domain becomes the range of the inverse, and the range becomes the domain. So keeping that in mind, if they're saying that the value that we need to find is the inverse of g with 1 over 16 as the domain, that means 1 over 16 is basically the range of the original function. So keeping that in mind, you put the function equal to 1 over 16 because the range is basically your y value and domain is the x value, equals to 4 to the power of x plus 3. Now 16 is 4 square, and we can rewrite 1 over 4 square as 4 to the power of negative 2 using one of the rules of indices. So once again, same thing. Since the bases are same on both sides, we can put the powers equal to each other. So negative 2 equals to x plus 3, and x is going to equal to negative 5. That's your answer. Question 19 says, we have a universal set which has the numbers 1 to 10. P is a set for odd numbers, Q is a set for multiples of 3, and R is a set for square numbers. So if we write the elements for each of the sets, P is going to be 1, 3, 5, 7, and 9. Q is going to be 3, 6, and 9. And R is going to be 1, 4, and 9. So part A is find P intersection Q intersection R, which means the common element between all three sets. So as we can see, the common element is 9. Then find Q union R, which means all the elements in Q and R. So that's going to be 1, 3, 4, 6, and 9. Then find the number of P intersection Q union R complement. So first, let's find Q union R complement. So we already found Q union R in part 1. Q union R complement means all those elements that are not a part of Q union R. So that's going to be 2, 5, 7, 8, and 10. Now, P intersection Q union R complement. So in P, we have 1, 3, 5 is common, 7 is common, and that is it. So how many elements are there? 2 elements. So 2 is the answer. Question 20 says the diagram shows two right-angled triangles PQS and RQT. PQR and QTS are straight lines. Calculate angle QTR. So QTR is this angle. This is what they're asking us to calculate. So if you look at the triangle PQS, they've given us PS and angle P, which means we can easily find the length of SQ. We'll use SOHCAHTOA over here because whenever they've given us an angle and a length, it's always ideal to use SOHCAHTOA. So we have the hypotenuse, which is always the diagonal, and we have the angle, and we want us to find the length opposite to the angle, so that's the opposite. So opposite hypotenuse sine. Sine of 28 equals to SQ over 18. So 18 times sine of 28 will give us the value of SQ, which is basically 8.45 centimeters. Now we know that ST is 4. That means TQ would be 8.45 minus 4, just 4.45 centimeters. Now to find the value of angle T, we have TQ, we have QR. So if this is our angle, 9 is our opposite, and 4.45 is our adjacent. So we can easily use tangent, tan of angle QTR equals to 9 over 4.5. So tan inverse of 9 over 4.5 will give us the value of the angle, which is going to be 63.69 degrees. That's angle QTR. Question 21 says solve the equation 3 tan x plus 5 equals to 1 for x between 0 to 360. So in order to solve this question, we're going to find the value of x. So to find the value of x, I'm going to first move 5 to the other side. So 3 tan x equals to 1 minus 5, which is equal to negative 4. Then tan x is going to be negative 4 divided by 3. Now to find x, we take tan inverse of negative 4 over 3, which gives us the value of negative 53.13 degrees. Now this negative sign shows that this angle exists either in the second quadrant or the fourth quadrant. Why? Because tan is only positive in the first quadrant or the third quadrant. In the second and the fourth, it's negative. So basically, we need to find the value of this angle and this angle. So first value of x is going to be 180 minus 53.13, which is equal to 126.9 degrees. And the other would be 360 minus 53.13, which is equal to 306.9 degrees. Always remember that you measure the angle in anti-clockwise direction starting from the x-axis over here, and you go towards the reference line, which is this and this in this case. So 126.9 degrees and 306.9 degrees. Both of these angles are in the given range. Question 22 says the graph of y equals to x plus 2 times x minus 1 whole square is shown on the grid. Show that y equals to x plus 2 times x minus 1 whole square can be written as y equals to x cubed minus 3x plus 2. So we just have to expand the bracket. X minus 1 squared is basically x squared minus 2x plus 1. So you replace that with this. Now there are two ways of finding the value of this. Either you can write this as x minus 1 times x minus 1 and expand the bracket, or you can use the formula of a minus b whole square, which is basically equal to a square minus 2ab plus b square, a being x and b being 1. So when you expand the bracket, we do x times x squared minus 2x plus 1 and plus 2 times x squared minus 2x plus 1. So that's x cubed minus 2x squared plus x plus 2x squared minus 4x plus 2. That would be x cubed minus 3x plus 2, which is the same as what's given in the question. Then part B says by drawing a suitable straight line, solve the equation 2x cubed minus 5x equals to 0. So now to understand how we're going to draw a straight line, we need to look at the initial equation, which is y equals to x cubed minus 3x plus 2. And over here we have 2x cubed minus 5x. So to turn this equation into this, first what we need to do is that we need to x cubed minus 3x plus 2. So to get rid of the 2 over here, that means there needs to be a plus 2, because when we will bring the 2 over here, that will eliminate the plus 2 and make it x cubed minus 3x. Now, second thing is, this is negative 3x, this is negative 5x, which means for it to become negative 5x, we need to have negative 1 over 2x over here. Why? Because when we'll bring these things over here, x cubed minus 3x plus 1 over 2x plus 2 minus 2 equals to 0. That's going to be x cubed minus 6x plus x over 2 equals to 0. Multiply the entire thing by 2. That gives us 2x cubed minus 5x equals to 0, which is the same thing as in the question. So this is the line that we'll draw on the graph to get the values of x. So y equals to minus 1 over 2x plus 2. Now at x equals to 0, y value will be 2 for this line. At this point, we have a coordinate of 0, 2, which is over here. Now, if we try to find the value at x equals to 2, so that's going to be y equals to negative 1 over 2 times 2 plus 2. That's negative 1 plus 2, and that's 1. That's 2, 1. This. So if we draw a line through these 2 points, we're getting 3 values for x. 1 over here, 1 over here, and 1 over here. This, and this, and this. So over here, it's negative 1.6, and over here it's 1.5, and here it's 0. So the values of x that I'm getting are negative 1.6, 0, and 1.5. That's my answer. Then question 23 says x minus 5 whole square plus k equals to x squared minus px minus 21. Find the value of p and the value of k. So you're going to expand the bracket on the left-hand side. So that's x minus 5 times x minus 5 plus k, which is x squared minus 5x minus 5x plus 25 plus k. So that's x squared minus 10x plus 25 plus k. Now this entire thing is equal to x squared minus px minus 21. So the quotient of x is negative 10 over here, and over it's negative p, which means negative 10 equals to negative p, and 10 equals to p. And here it's 25 plus k equals to negative 21. So k would be negative 21 minus 25, which is negative 46. So that's the value of k.